Nehoma TikTokers. It's how's it going in Mandarin? Cool. It's actually ni hao in Mandarin. Neho is Cantonese. Anywho, here we go. Today we are going to start briefly 6.4. And in 6.4, we are starting to build away, not necessarily away from, but blend this idea of chemistry, which has been pretty much the main focus, and start transitioning back into this lovely biology. So in 6.4, our focus is on the building blocks of life. The building blocks of life. Okay, so we get a little tiny bit more chemistry, and I know exactly where I want to get to today. You guys will be working on stuff while we finish or continue to watch the game. Our main focus today is on this idea of what we're going to define, and it's going to be a definition real quick. Organic chemistry. Now, if I ask, and this is there's not a real true answer, but what's the most important element on the periodic table to you guys, do you think?
Oxygen.
Oxygen's a natural thought because we breathe it. Sure. Oxygen's important. Guaranteed. Like, yes, you are correct. However, I think that if we look at from a pure biological standpoint, we, and just as a whole species, as life on this planet, there's one that's a little bit more important than oxygen, although it is fundamental as well. While we look at this, organic chemistry is the study of chemistry. So I'm just going to say chemistry regarding one particular element, and it's going to be carbon. All right. Now, we as humans and anything on this planet, if you say what type of life are we, and it doesn't matter whether you're talking about a human or an insect or bacteria, it doesn't matter. We are a carbon-based life form. Carbon does some special things, so special in fact that there are entire buildings in universities that its only focus is carbon and organic chemistry. And today we're going to look at why is this so stinking important. So, do me a favor. In your text, most of you have it open. If you don't, just share with somebody else. Go to the periodic table for me. And what I want to look at is I want us to start thinking, why is carbon, and remember I'm going to use this shorthand, why is carbon special? Now, if we look at carbon, just hook it up. Carbon, anybody opposed before I just say I'm going to do it? Can I just use this for the word carbon every time?
Yeah.
Okay. Carbon is where? It's in, not like in your table, I mean. Where is carbon? What? Period 2. And group 14. Now, this has been a while, but what does the period of an element tell us? The rings. When we say the rings, what are we referring to? Energy levels. So I know it has 2 energy levels. Okay, I'm good with that. What about the group? What does the group tell us? That it's in 14. So the positive and negative, there is some stuff there for sure. It is going to tend to be positive, but there's something more specific. The outermost electrons, do you guys recall what we named them? So covalent is when they share their outer electrons. That co part is a sharing. Co what? Valent. Valence. We have 4 valence electrons. Now, as we look at it, I wish I had a model for this, but what's a magic number of electrons that we want and everything wants?
8.
8. Now, if I asked you for something in group 1, lithium, for example, it has 1 valence electron, right? Is it easier to gain 7 or give 1? Give 1. So it gives them up, right? If I go to the way other side, chlorine has 7 valence electrons. If it wants to get 8, it can either gain 1 or it can get rid of 7. Gaining 1 is easier, right? Where's the only place that it's going to be like, oh, I don't know if I should give or take? If I have 5, is it easier to get 3 or give 5? Get 3 is easier. What about 4?
That's where it gets tricky.
It gets tricky. Why?
Because neither of them know to give up or gain.
Yeah, it's the same effort either way. So it turns out that that is one of the really, really special parts of this. When we think about how elements bond, whether it's ionic or covalent, it's about electrons, right? Ionic means electrons physically move. Carbon does not get rid of 4 electrons. It won't get rid of 4 because it's like the hardest possible amount of electrons it can get rid of. Which means carbon likes to really commonly use covalent bonds. Now, if I have a carbon atom, and I'm going to draw a super lazy picture for this so we don't have to draw all the dots. Just so you know, mine has all the dots and I colored it because I'm a nerd. Cool. Here's carbon. Here's the nucleus. And you guys would probably benefit from this. Now, how many electrons does it have? Valence?
Oh, we talked 4.
4. Good. Now, with this, I wish I had a 3-dimensional figure. But if I think of this in flatland and I space these, I'd see 1, 2, 3, and 4 valence electrons, right? How many different elements then could stick to this carbon? Like, for example, if I had, give me, like chlorine, right, is in group 7 and it needs 1 more electron. Could you stick a chlorine right here and they would balance? Why no? So they do, but if chlorine needs 1 more electron, if it got to share it here, it would get it, right? Could it stick on here too? And here? We could do 4 of them, right? Now, in reality, it's not 2-dimensional. So the way that it would look is if we have a sphere, so I'm just going to use my fist. I would have one, I'll get this back. One would spit out here, one would spit out here. It'd be like a tripod with a neck on top. So that we could gain on and like separate ourselves between them. As we look at this, the fact that that can grab onto 4 things is huge. With 4 valence electrons, and we're just going to write this statement in a nice clear way. With 4 valence electrons, and what's the shorthand for electron again? E negative. With 4 valence electrons, there are, and I am going to use just common language here to make sense of it, and then we can probably write down more formal. If I think of where stuff can grab on, think of it like a handle. Are you guys okay with that? Like, if I have 4 handles, I can grab on or join at 4 different places. There are 4 places to join. Now, and I'm going to say 4 atoms to stick. And I'm going to say bond, realistically. Because we have these 4 valence electrons, there are 4 different locations on any carbon atom for which another element can stick to it to make a new compound. Now, if alien life exists, which I imagine I've asked you guys this before, but I don't know, do you think that elsewhere in the universe life exists? Not necessarily smart and alien like us, but do you think there's other places in the universe where life is?
Yeah, I think kind of no.
Cool. I'll tell you, this is not truth, right? Like, I don't know the answer. So I guess teacher hat off, but just logic hat on. There is so much universe out there. I'd be shocked. I would be shocked if there weren't other life. Whether or not we discover it, I don't know if we ever will. I would be so shocked if we were the only life in the universe. I don't think we're that special.
Wait, have we like found like any bacteria or anything
Nope.
in space?
Nope.
Nothing yet?
But I mean, we haven't gone very far. We're
How far have we gone?
like people themselves,
Yeah, like
the moon.
That's about as far as space is.
Literally as far as human beings have gone. We have a single probe called Cassini that's past Pluto at this point in time that we launched in the 70s, and it's just flying. It's just going. But at this point, it takes like months for data to get back because it has to travel at the speed of light, but it's so far away.
So is it like a machine all the way out at Pluto? Just
Past Pluto, oh yeah.
Just floating
One.
around?
Yep, it's just floating out there, still sending radio signals back.
Can we send
Okay,
it? Wait, sorry. I'm just.
You're good.
Actually, like mind blowing.
it's been flying for 30, 40, 50 years. 50 years it's been going.
Is it like just like when
And
you
it's
send
less
it-
than a tenth of a percent across the universe. If you started now and going at the speed of light, at least 70 billion years is what it will take you
to get all the way out to.
to the universe, across the universe. The universe is huge. Anyway, the fact that this happens is huge. Carbon can join in a bunch of different ways, but I think this is a good place to leave off. If you were an alien, like if we're looking for life out there, we only have ever seen carbon-based life. On the periodic table, what other life do you think we might find instead of being carbon-based, can you tell me another element you think might reasonably make life?
Oxygen based.
So don't guess. Look at it. Oxygen does not, like, is there another element that has 4 places to grab onto?
Wait, how do we know if that has 4 places?
It's the number of valence electrons.
Is the one digit like
What else has 4 valence electrons? Or reworded, what else is in group 14?
silicon,
If
germanium?
if there's another life form out there and it's not carbon, like we happen to have carbon on this planet, there's possibility that aliens could be silicon-based life forms. Because organic chemistry and how carbon has these places to join on, silicon also has these places to join on. Turns out on our planet, carbon is way more prevalent than silicon. So we, by whatever reason, wound up as carbon-based. Silicon-based life forms probably exist in my mind. Now, that's not, don't take that as anything special, that's just me saying I think it's probably happened. Cool. All right, class is over, but you guys can hang out for 10 more seconds.
What if it like were to just like vanish?
What were?
The machine that's like way out there.
We wouldn't know it for a long time, first of all. I can point you, this is interesting to you?
Yeah, like that's I never knew that there was something. Just
Oh,
like
man,
way
yeah.
out there.
I don't know when, but I have a space documentary that's like my favorite that I've ever watched. It's from like 2007. It's called Journey Across the Universe. I'll hook it up. Come talk to me at lunch. I can point you towards like a bunch of YouTube channels and books and stuff to listen to if you're interested. All right, later, Raiders.
Like that would
Yes, absolutely. That's not what I meant to do.
That was weird.
What?